right, guys. I get asked all the time about ring gaps. You guys buy parts from us. You want to assemble your own stuff. So we're about to assemble this short block. I got to move my fingers. That K-Series sleeved short block for a 700 to 1,000 horsepower automatic rear-wheel drive K-Series. So we're going to check out how to do the ring gaps. I'm going to make it applicable for even your stock rebuilds, and we will go from there. Let's check it out. All right, what is a ring gap and why do we do it? We got everything laid out here. It's dirty. It's actually not dirty. It's a clean piece of cardboard, but that's our clean room, and it is full of stuff, full of engines currently, and I need to get this bad boy done. So this is cylinder 1. I have loaded the rings in there, as you can see. Still got to clean the block, but you see a little discoloration from the iron sleeves, but we got our rings in there. See the little gap right there, how the guys are basically touching right now? That is what you do when you're setting the ring gaps. We're gonna file or grind, or you can chew on that thing with your teeth if you want to, just to make the gap what it should be. So what happens is, the more horsepower you're making, the more gap you need. What you don't want is those guys to touch during a pull or whatever. That's bad news. I get asked all the time about what ring gaps people should run, so I figured it'd be about time for me to tell you how we do it and how you should do it. So I don't know if I can make you guys see this, but we got our 19 here. These guys out of the box, there ain't no chance of that fitting in there. So whatever your pleasure is as far as doing this, you can buy a fancy guy, you can use a file, anything like that on this first step. We're going to take these bad boys off, and we're going to get to filing. So there's a couple of important details here. We've got this guy ground. I use just the same side on all of them. And I haven't cleaned them up a whole lot yet, but I don't know if you guys can see it. I'm trying to see it through the tag on it. Trying to look at it through the camera. We got our ring gap pretty happy here. What we want also is the two sides to be even. We don't want one side sticking out a whole bunch more. I got to file, see the top side just a little bit closer than the bottom side. So I'll level on that a little bit, and we're gonna take a file and hit the edges and make sure there's nothing you can drag your fingernail on, like in this direction and the top side. Because if not, you'll get a big nasty gouge up and down the cylinder. We don't want that. So that is our top ring done. So we're gonna file these down and clean them up and go from there. All right, so this is the second ring installed. A little bit bigger gap natively than the first ring. And I should point out that there's going to be times I've noticed when you're doing a stock sleeve block where you end up having the ring gaps already bigger than it's supposed to be. And as long as it's not huge, then it's not a huge deal. But we're going to file these bad boys and 1 to 21, and we'll be ready to drop some pistons in some holes. So I've got a little cheat sheet here from Wiseco, and I'll give you guys some numbers to work off of. And this is for their pistons, but I've found this to be pretty universal. What we're going to do is we're going to do a little bit of math. You are going to take your bore size. Let's say in this case it's 87 millimeter block, and you're going to have to figure out what that is in inches. So it's pretty easy. That's I've already got a cheat sheet made. 87 millimeter divided by 25.4. There's 25.4 millimeters in an inch. So when you do that math, you end up with 3.43. So we are a 3.43 inch bore. So I've got a couple of different options depending on the engine's goals, and we are going to do the math to finish that up. So this is the Wiseco sheet, and I've kind of put you some Sharpie marks. This is the stuff we deal with mostly. Most of you guys are going to use something like this right here. So let's say, we're actually going to use a little bit more on this in this case, but let's say that we are building a 500 to 600 horsepower, which is most of you guys are going to do. 500, and it doesn't really matter whether it's BD, HK. For most engines, this is going to be pretty well, you know, the way to look at it. what we're gonna do with our little calculator, I got this old Amazon calculator here. We got our bore in inches, right? Times, not divided by. And what we're gonna do is we're gonna do 0.005. We're gonna do 4.5 thou. Bam. We end up with a 15 ring gap. All right. That would be what I would consider minimum. You can go a little bigger. You know, the difference in a 15 and a 18 might be you deciding to turn the boost up some. So a little extra might not be bad. I actually did the math on the variance between all of this. You've got your bare minimum right there. You got your maximum. That's a 0.15 to an 0.28 on the top ring. But anyway, for our stock block here, we got 15. And in order to make that for our second ring, we're adding half. So it's 0.0, well, actually it's a whole on this one, 0.0055 times. This is about a 19 top ring. So we're looking at 15 bottom ring, 19 top ring. You can just kind of guess at this after a while. Like I'll do the math on my bottom ring and it might be 18 and I'll make the top ring 21. I know it's going to be close. So in the engine we're doing right now, we're actually going to use the street moderate turbo nitrous-ish. So we're going to do 3.43 times 0.005 equals, we got a 17 top ring. So I've got my 17 top ring right there. See that? Probably actually going to go more like 19. But on paper, 17 is it. And it says here, second ring is a 0055. We're probably going to go a little bigger with that. I have personally seen that it doesn't seem to matter, or it makes more power. 0.20. So we're going to go to 0.21. So let's go 0.19, 0.21. So to add in there, this is everybody asked me, well, what? That's too big. That's too big. What if it's too big? I'd rather go too big than too small, because what happens is if it's too small, if your ring gaps are too small, then everybody knows. If your ring gaps are too big, then nobody knows. If they're too small, you're going to have engine problems. So we'd rather go a little big than a little small. Keep that in mind, guys. So I guess one of the things that I had never shown, guys, is how I put the rings in. So I will take them like this. Start them this way. By hand. Takes a little feel. It's pretty easy. Take a piston. It can be connected to the rod. It doesn't matter. Shove them down in. Keeps them level all the way around. You do want to check this deeper in the cylinder, but currently I'm pretty all right. But got a 21 here. Everybody looking pretty good. Everybody looking pretty good there at 21. Oh yeah. Yeah. Anyway, so a couple things. I'm gonna clean these guys up in a second. One of the things you want, guys, you want to make sure when you push these guys together that there's no gap. I don't know if you guys can see that or not, but we don't want to cut it off that way. Now, one thing I've noticed, I always pull these things out, because the cylinders are, sometimes it's a little bit different. It shouldn't be anything crazy, but I put them where they go. I've noticed that the second ring, the material it's made out of, I don't remember, I could go back and look, but usually the second ring leaves a little bit of, just you can rub your finger across and you can barely catch. So, show you what I do for that. So, I got my file. Use the flat side of my file. Literally, it takes almost nothing. Just, I'll go through all the rings this way and make sure that there's no. And you also should check the factory edge just to make sure that there's no machining issues. But rub your fingers across, and you can't be too careful with that. So anyway, I don't really care what you use to file them. I'd make sure you have a normal file. I try to make sure that the file I use for this portion of it is something that, basically something that I only use for engine stuff. I don't know that that is a big deal, but maybe. I have used everything from a bench grinder to a handheld grinder to gap rings in a field. And we have been 450s in the 8th on engines that I have put together in a field. So it's really more about the hands doing the work than it is about the tooling when it comes to this, as far as I'm concerned. Somebody will argue with me, I don't really care. Our engines don't smoke. They do really well. That is the gist for me here. We've got the rings done. I'm gonna drop these guys in the hole. Check out the bearings and stuff and make sure they're good to go. That should be it, guys. It's pretty simple, pretty straightforward. Like I said earlier, we are going, you know, we do the math, figure out what our bore size is in inches, do a little math. I'll post a picture of this chart here. You can use it by default on basically anything CP, Wiseco, JE, any forged pistons. You can use it on nip and racing pistons if you really want to. I use the same thing on Vitaras, etc. Remember, loose is better than tight. Loose is fast. Anyway, appreciate you guys. Grab you a t-shirt off the website, a hat, some stickers. Buy some parts if you need it. We got used stuff floating around all the time. New stuff all the time. Try to keep as much stuff in stock as possible. Love y'all. Have a good day.